We're going to review here how to get the information you need to develop your simulation model for options pricing and for simulating options strategies. So I'm going to use in this case the stock XOM, which is ExxonMobil. And so a couple of things we need are some of the current options available, and then also the stock prices to calculate the parameters we need for the geometric Brownian motion. So for the options prices, I'm just going to go to Yahoo Finance. And you can put in a company up here, so I'll put in XOM. And the first thing I'm going to do, this is as you can see, as of close September 6th, is just go ahead and make sure I know that the stock price right now is $112.64. So and just note that that's XOM as of September 6th. So what part of the key to this is we want to pull off the options prices and download the stock prices and then get the current price all at the same time. So now what we can do is for ExxonMobil, go over here, there's a link on the left that says options. And it brings us to this page which shows options. I'm going to pick one that's a few months away. So these are the time to expiration of the options. Okay, so you can see there's a lot of choices. And I'll just pick one that expires in, say, January 17th. And so if you scroll down, you see all the call options that are available. And then there are put options available. And so you can print a PDF of this page. I've had pretty good luck just highlighting all of these and copying this, and then go ahead and paste it into Excel, and have to do a little bit of formatting. But I'll put up here, these at the top are call options. And we can do some formatting of this. It's not all that important, but that's not formatted too badly. Okay, so that gives us some options prices that we're going to need. And so at the top are the call options, and if we scroll down a little ways, we should at some point here see the put options. Okay, and important to remember, I'm going to put up here that the expiration date was January 17th for these options. Okay, so that's how we can get our options prices. Now, if we want to go ahead and get the stock prices to calculate the parameters we need for geometric Brownian motion, we would just open, the best way is to use Anaconda to do that. Okay, so to use Jupyter Notebook, use Anaconda to get the stock prices. I've just re-downloaded from Canvas this Prices One Python notebook. So I've navigated to the folder where I saved that. And so now I've got my Jupyter Notebook open. And so I'm going to run these first few. Shouldn't need to install Y-Finance again. So I'm going to use XOM, and then I'll just end on September 6th, because that was the day the options prices were pulled up. And then the question is how much data to use. I'm just going to use, I think, 5 years worth. So I'll go back to 2019, say September 7th, and that would be 5 full years worth of data. Now, the best thing to do is to go ahead and just do daily data when you're estimating the geometric Brownian motion parameters. So in that case, we could just take off the interval because daily data is the default. So it'll run and then show us our data. And I'll rename this data frame XOM since that's my new stock. And so I've got the stock prices. Now what we need to do for geometric Brownian motion is, of course, calculate log returns. Changing this description here is optional, and it's a different type of code called LaTeX, but you can do it if you'd like to. Not required. Okay, so we're calculating the log returns, and that really assumes compounding. As an additive return. All right, so we'll change this and calculate the log returns. And we'll change this to XOM because that's the stock that I've got. And nplog is the function in Python that will give us the natural log of that quantity. Okay, and so remember, this is just the current price divided by the previous price, which is the shift. Okay, so here's our log returns. I'm just changing this to XOM as I go. And so there's our log returns. They're centered around 0, of course, because they're more like additive returns. And we'll go ahead and drop the first return. And the first date is 2019, September 9th. Must have been the first business day in my range. Okay, so we've got the XOM returns. Now what we can do is we could also go ahead and calculate the mean of the returns. So I'm going to insert a couple of cells above and we can calculate the standard deviation. So let's do the mean. This, of course, this structure here is called a data frame, and I've named that XOM, and so a column in there is log return, and that's the one that I want to find the mean for. So there's the mean of the log returns. And then we can also get the standard deviation. Standard deviation actually is just STD in Python. And so that's the standard deviation. And if we want to, we could go ahead and calculate in Python here the GBM parameters. So I could calculate the mu hat. I actually just have my textbook open here so I can refer back to the formulas. Here's the mu hat. Of course, this R bar is the average returns. And S is the standard deviation. The delta that we'll use is going to be 1 over 252 because we have daily data. So let's do that first. I'll just define delta so I don't have to keep putting it into the commercials. So the formula is it's the mean divided by delta plus the standard deviation squared, and that's the exponent. Let's check this to make sure. Standard deviation squared divided by 2 delta. So that should give us our mu hat. And sigma hat is just the standard deviation. Oops. Divided by the square root of delta. And one way to get the square root in delta is just to use the double asterisk, which is exponent, and then 0.5, because the square root is the 0.5 exponent. So there's our sigma hat. So these parameters are what we need to include in our simulation model for the geometric Brownian motion. If I want to have my returns exported, of course I can use that. Since we've done the sigma hat and mu hat in Python, we wouldn't necessarily have to do that. But anytime we want to export the returns, we can do that with this command.